The chemistry of water. Water has a wide V molecular shape. So basically, it means that water is a polar molecule and it also has a polar covalent bond. The polar covalent bond means that the oxygen is more electronegative than the hydrogen. So hydrogen is drawn to oxygen. Hydrogen has a slight positive charge, whereas oxygen has a slight negative charge. So that makes it polar because of that opposites attract kind of thing. It's a polar molecule because the overall charge in the molecule is unevenly distributed. Again, there is a slight negative charge and there is a slight positive charge going on, and they're going to attract to each other. So water-hydrogen bonds, which is a huge concept. So basically, atoms in neighboring water molecules with the opposite charges, the slight negative and the slight positive, will be attracted to each other and form these things called hydrogen bonds. So here, the hydrogen atom and the oxygen atom are going to form a hydrogen bond by that attraction. If oxygen and hydrogen were equal charges, like if they were both negative or if they were both positive, then water would no longer be polar and there would be no formation of hydrogen bonds. So water has three different forms. It's in liquid, solid, or gas. So ice, liquid water, or vapor. And it happens through the addition or the removal of energy. So basically, the hydrogen bonds play an important role in that, because when you add energy or when you remove energy, something happens to those hydrogen bonds. For example, in ice, the hydrogen bonds are really, really strong. So they form these structured kind of crystallized shapes. And when energy is added to it, so heat, and it melts, it turns into this liquid. And here, as you can see, the hydrogen bonds are less crystallized and it seems like they're more undefined. And that's because melting occurs when water absorbs the heat, so it breaks the hydrogen bonds. And in the liquid formation, the hydrogen bonds break as fast as they form. So here they're less defined, as in here they're really, really defined, and you have that crystallized shape. When more heat is added, the water starts to evaporate, and in the water vapor form, the hydrogen bonds break faster than they can form. So here you don't see them like bonding together, they're very far apart. When you remove that energy, the opposite happens. When you remove energy from water vapor, then the hydrogen bonds begin to form again. So they still break, but they're forming just as fast. When you remove energy from that, you're freezing it. And so then it becomes like a crystallized shape, and the hydrogen bonds become really, really strong. So basically, water has surface tension, capillary action, adhesion, and cohesion through hydrogen bonding. The cohesive behavior of molecules means that the water molecules are close together. So the molecules become more structured through the linkage of many molecules by hydrogen bonds. It's kind of like a chain link. They stick to each other. Cohesion is the bonding of water to itself. Again, they stick to each other, kind of like a chain link, and it attributes to the dissolving of nutrients and transportation of water in plants. Capillary action is the movement of liquid along a surface of a solid caused by the attraction of molecules of the liquid to the molecules of the solid. Basically, this is really important in the transportation of water in plants. So with the combination of cohesion and adhesion, water can be transported through plants. So how that happens is, as water evaporates, the hydrogen bonds through cohesion cause a chain-like pull of molecules upward. Then, through adhesion, the molecules counter gravity by bonding to the plant walls. And as you can see here, the adhesion happens to the plant wall. So adhesion is the formation of hydrogen bonds between water and another substance. In this case, it's cell walls. So the water molecules will bond to the cell walls, but they're also bonding to their self. And as it's pulling upwards with them bonding to themselves, they also get to stick to the cell wall, which keeps them going up. And that's capillary action in plants. Surface tension is another huge property of water through hydrogen bonding. So basically, surface tension is the measure of difficulty to stretch or break the surface of a liquid. As you can see here, the paper clip is laying on top of the liquid. It's not really breaking it. It's not, when it breaks that surface tension, it would sink. So as you can see, water has really high surface tension for the paper clip not to break through. And that's because the evaporated molecules, water molecules in the air, as you can see here, they act as an invisible film. And so the water below forms a hydrogen bond with it, which increases the surface tension of water. So all the water molecules up here and the water molecules down here are hydrogen bonding, which causes that invisible film, which increases its surface tension. So you can't really, it's really difficult to break the surface of water, liquid, with small little things. So as a review, water has a wide V shape, which makes it polar. That polarity causes a hydrogen bond to form from the opposites attract concept. And then through that, water can have different forms. Water has properties like surface tension, capillary action, adhesion, and cohesion. Cohesion is when water bonds to itself. Adhesion is when water bonds to another substance. Capillary action is the movement of liquid across a solid. So the water is going to bond to both itself and to that solid, and that's going to help it move along. And surface tension is the difficulty to stretch or break the surface of a liquid. And water, remember, water has a really high surface tension.